In circle ABCD, just going over the points on the circle. Okay, and I'm noticing there's no center. Okay, they tell me that AB equals BC. They've marked that out for me. I'm going over it again, and I'm looking at a corollary here to angles in the same segment, which is equal chords equal angles. AB subtends angle D at the circumference, and BC subtends angle A1, but also AB subtends angle C. So you've got this one chord, the AB, this subtends two angles in the same segment, the D and the C. But then because we've got another chord that's the same length in the same circle, they subtend the same size angle at the circumference. So I've got a whole bunch of things equal to each other. Okay, I saw that that was the circle. I marked out everything that that gave me. Prove that AB is a tangent to what is now a non-existing circle, AED. So I'm going to attempt to draw a circle around there so I can see what it is I'm trying to prove. So when I've got to prove a tangent, I'm mostly going to prove tan chord. I'm just talking statistically here, what mostly comes up. I could be proving tangents from the same chord, and I could be proving tan rad. But right here I can see that I'm supposed to prove AB is a tangent to this other circle, AB. Let's just get ourselves clear here. AB would go like this, and I do believe in extending tangents. Okay, that is AB. So what are we actually trying to prove? If we're trying to prove tan chord, and that's the only thing we can do here, I need to prove that A1, which I have obscured there with my circle, this one here, A1, okay, so I'm actually required to prove that A1 equals one of the things that is subtended in the circle. So A1 would go to AE, and then AE makes D in the circle. So I've got to prove that angle A1 equals angle D. But you can see on my diagram, I've already done that. So what I've got to do now is walk through how I got there. I'm going to start with saying that I've got A1 equal to C, because I've just seen a different way of looking at it. It's actually angles opposite equal sides, that AB and BC being the equal sides. I did it another way a moment ago, but I thought I would share that there's an isosceles triangle there as well. So I'm gonna use that because it was actually shorter. So my reason was angles opposite equal sides. But then I have C equals D. And that's got to do with angles in the same segment. Therefore, D equals A1. Therefore, we have a tan chord. Okay, so therefore, AB is a tangent to circle AED, and my reason is converse tan chord, because I'm proving a tan chord. Okay, so if you're proving anything, you're going to say converse. If you're proving something that you can normally use. Okay, now I did talk about equal chords, equal angles, so I could have done this even quicker. I could have just said, well, BC subtends A1, AB subtends D, therefore, I could have said alternatively here, I could have said A1 equals D, and I could have said equal chords, equal angles, and then gone straight to my answer from there. Here I'm told that ALB is a tangent. So I'm going over the tangent, and I'm looking for tan chord now. There's only one tangent, so it's not tangents from the same point, and there's no center, so it's not tan rad. So I'm looking for tan chord. Okay, so L3 would be the same as P1, so I'm going to make that a single bar there, and L4 would be the same as M1. You'll make that a double bar. Okay. Right, that's tan chord so far. Then they tell me that ALB is parallel to MP. So I'm going to go over the parallel lines. And I see then that the parallel lines give me a whole bunch of alternate angles. So actually, there's my Z happening there. Okay. Actually, L4 is the same as P1. Right, so that means that all my single bars can now become doubles. It's convenient that I chose that way of marking it out. And so they're all equal to each other because of tan chord and because of alternate angles. Okay, I'm not seeing anything else that's interesting coming from those two bits of information. Let's see if I can answer the questions based on what is already marked out on the diagram. So I need to prove that LM equals LP. And obviously I'm not dealing with sides here, I'm dealing with angles. So let's have a little look at what I'm actually required to prove. So let me translate what the question is asking. LM, see where that is? And LP. Okay, so I'm actually required to prove that M1 equals P1. Then I've got sides opposite equal angle. And as you can see, I've already done that. So now it's a matter of laying it out. Okay, so where did we start? We started with tan chord, and then we used the parallel lines, and then we put them all together. Okay, so I'm going to try and find the quickest way through here. I'm going to say, well, L3 equals P1, and that was tan chord. Then I'm going to say, but L3 is also equal to M1, and that's because of alternate angles. And then quite logically, if L3 equals both of those, they are clearly equal to each other. But that wasn't finished because that's what I realized I had required to prove in order to get the rest of it. So then I need to say, therefore, LM equals LP. Why? Because those lines are sides opposite what I am given, which is the equal angles. Not given, I suppose it's what I've just worked to get. But the reason this has to be sides opposite equal angles is because I'm working from the equal angles to get the equal sides and not the other way around. The next thing I've got to do is I've got to prove that the line LN bisects M and P. So M to N to P is this one by N1 and N2. So what I'm actually required to prove from here, I'm actually required to prove that N1 equals N2. Okay, so in order to do that, I need to think about what else I can get from when it comes to N1 and N2. So I haven't marked them out yet on the diagram. Let's have a look. What subtends N1? It's the angle coming from LM. So LM subtends N1, but then it's the same as P1. Okay, so what I had not marked out earlier was my angles in the same segment. But it looks like it's going to go the way I need it to go now, because what about N2? N2 is going to be the same as M1, also because of angles in the same segment, or things I've already proven. Okay, so I've got N1 equals N2, and now I need to lay it out. So N1 equaled P1, and that was angles in the same segment. But then I've got M1 and N2, but remember I actually already proved this thing here. That's already proven, okay? So I'll come to that in a moment. Then I'm going to say N2 equals M1. It's the same reason. Therefore, because M1 equals, my last bit of information was coming from a previous question, and that's something we need to bear in mind. It's what I'm calling scaffolded questions. Okay, the one comes from the previous one. This is proven. Okay, and then therefore, because P1 and M1 are equal, it must be N1 and N2 that are equal. Does that do what I needed to do? Yes. It then proves that Ln bisects the angle MNP. Then I've got to prove tan chord. I'm just going to extend this thing that's supposed to be the tangent. Okay. And the reason I know it's tan chord is, again, there's no possible center and there's no two tangents from the same point, so I have to be proving tan chord. Okay, now where is it? Well, it would be that M1 equals the angle subtended in my pink circle, which is N1. Okay, but I've already got that, already proven it. So all I'm doing is actually just putting it together. So for question C here, I am actually required to prove that M1 equals N1. Okay, but I've already got all of those things together. So I'm going to say, but I've just actually proved. I've just proved that N1 equals N2, and that is proven in question B, right? But then I also have that M1 equals N2, and that was angles in the same segment. Therefore, N1 equals M1. Therefore, LM is a tangent to the circle MNQ, and my reason is converse tan chord.